Hi, my name is Marco Cantu. Welcome to this CodeRage 9 session focused on enterprise mobility services and specifically on working with SQL databases when building mobile applications that hook to your remote enterprise data source. My name is Marco. I'm product manager at Embarcadero Technologies for Delphi and RAD. And this is my contact information by email or Twitter, where you can engage into conversation during CodeRage 9. So what the specific focus of this session, as I was mentioning, it's looking into data and mobile challenges, comparing different solutions on the mobile data space, and then focusing specifically on what enterprise mobility services provides from this perspective and delving into some actual demos of using FireDAC with this technology. It's not an exhaustive session on enterprise mobility services. There are others in the program of CodeRage, so the focus here will be specific to database side and less focused on the analytics, the core API management, and some of the other areas of the product covered in specific sessions. So data and mobile. We all have mobile devices and they won't be terribly useful without the ability to access to data that lives outside of the device itself. That's even true for most games that require internet connections. Mobile data access is not client-server access. There are technical ways, in some cases, in some scenarios, to do direct client-server access from mobile, but the lack of drivers for most databases, in some cases, licensing issues for those drivers, but also connectivity issues. When you're connecting from mobile, you might move from a Wi-Fi to another Wi-Fi, from a Wi-Fi to a 3G connection, and your IP address will keep changing. So keeping an active connection via TCP/IP is generally a mistake, even if you can go through VPNs and similar technologies. And last but not least, there are security concerns in opening up the access to the database server from the outside, because you really want to have a well-guarded entry point, possibly via HTTP or some clean standard that you can monitor actively for access. So what ends up being the most common solution for getting enterprise data on mobile is some remote storage and based on multi-tier technologies. Now, there are many different approaches, but we can somehow summarize them into areas. One, you build your own web service with some SDK. Could be a manual, low-level web integration. Could be something like DataSnap that we offer. Could be other solutions, depending on the technologies. Could be Java, .NET solutions that you deploy for data access, and then you simply create REST clients on your devices. Or that's getting more and more popular, specifically in enterprise scenarios. Rather than do it yourself, deploy a ready-to-use solution that allows you to hook into the specific data access that you need, but without having to reinvent the wheel and redeploy and rebuild an entire custom solution. That's what's generally indicated as MEAP, or Mobile Enterprise Application Platform. Now, there are different scenarios that can be used for different types of data access. And again, there are dozens of different variations, but we can somehow summarize them in three categories. One is pure cloud hosting. A good example would be you have an application that saves files and you want those files to be backed up on your personal cloud. Could be Dropbox, could be Amazon, could be Google, could be Microsoft. Doesn't really matter. You as a user have an account on this cloud system, and you have your documents backed up to that cloud system. This is user-based. It's not, or it's generally not, the application that offers the data access, although Dropbox will be an exception to that rule. But it's not the mobile-specific application that provides that access. This is what happened with BAAS services. Backend as a service providers offer you a solution that's not user-specific, but it's application-specific. So you build an application and you have storage for all of the users of that application. This a solution that scale, offer great social integration. They're generally based on vendor clouds and offer some data storage in terms of specific tables, specific data structures that can be used. But it's basically an end-to-end closed solution, meaning your application and the backend create an ecosystem that is self-sufficient, but won't easily connect to the outside world. This is where the big difference comes with MEAP solution that are meant for corporate users, tend to be slightly more expensive in terms of per user cost. But the goal here is not to have their own application data, but be a conduit to the enterprise databases that you need to access to, whether sales, whether inventory, whether warehouse management, whether any other thing you're doing in the business side. You can generally have its own specific or particular data storage, but it needs to hook and provide access to the real data that is used to run the company. The other thing that's very important for this mobile backend solution is, rather than having them on the vendor sites, they can be self-hosted. This means you provide your own security. They are behind your firewall and hooked to your enterprise databases with a secure and safe connection, and are also scalable in terms of, again, data access. Now, you can cloud host them. If your data is in the cloud, then it would make sense to have also these services hosted on a cloud provider. The other thing I want to mention to complete the roundup on data, we do have data that lives in the cloud or on MEAP or enterprise databases. However, it's usually a hard call not to have some data on mobile, if just for caching. If you have to re-download description of thousands of products you're selling every day, or every time you run the application, that would be a complete disaster in terms of bandwidth usage. But there is more. You might have temporarily lose your connection and still want to be able to do things and collect information and even enter and edit your current information for later synchronization with the servers. So caching, keeping local data are relevant features to having data on the device, readily available when the applications get restarted. Now, there are security concerns in this scenario different than the connectivity concerns or hackers getting into your system. Here the concerns becomes, what if I lose my device or the device gets stolen and someone has an option to look to the physical files that are there. It might be an issue, it might be not. It actually depends on which data you are saving and how security and how you are managing any sensitive data that might even be legally concerning to if it becomes available to the outside. Now, there are multiple grades of solutions in RAD Studio. You can use local tables. Just grab an FDMEM table and save it to a binary local stream. and you are in business for local caching, now that means that the table is going to be reloaded in memory, so it's great and it's extremely powerful. You can even do joins of multiple FDMM tables on your local device as if it were a full database. But if you have thousands or hundreds of thousands of records, you might want to have a local full database because it reduces the memory footprint. You're just querying the local database and loading a bit of the records at a time rather than loading them all. So IB Lite is a free solution that scales better and provides reduced memory footprint in some of the scenarios. Really depends on what you're actually doing. IB2Go is the next step because it's technically identical to IB Lite in terms of reduced memory footprint and capabilities, but it also allows for encryption of the database data. So you can get to a fully secure application end-to-end, not just making the connection to your backend secure, but also keeping a secure local cache on the device that prevents anyone from looking to your company data in case they can get a hold of those files. So EMS is a MEAP. It's one of the solutions that you might want to use. Again, depending on your scenarios, you might be better off with a BAAS, you might be better off with a cloud service, you might be better off with a completely custom SDK, but we are pretty sure that EMS offers some significant advantages to other scenarios if enterprise data access is your goal, because it's fast to build and it's fast to deploy and still provides a lot of flexibility in terms of deploying both on-premise or in a private cloud. It has security focus and it has a lot of other features already and more to come later, including right now, for example, the usage analytics and the REST API calls analytics that are part of the box, and nothing to do, you just deploy it and you get analytics readily available with really no effort. If we look at the entire picture, there are a few areas where databases come in. There is an Interbase2Go license included in EMS for securing the data on the device. There is an EMS database, which is actually an Interbase server that keeps the information for the console, the users, the analytics data, and more. And then there is either Interbase server, which is included for free if you want to use it, or you can hook to any other enterprise database through FireDAC. You can also have conduits to some of these other cloud and BAAS providers if you need that. But in the most common scenario, you'll just use FireDAC in your EMS plugin packages to connect to enterprise data. So as a roundup, the EMS architecture has a server that lets you expose REST APIs. There are some already built in, but you add more, creating custom packages that register new resource URLs. The EMS database stores some of the information, and then there is a console, which is another server that has a web interface and used for tracking status and usage. To deploy, you can deploy the EMS server and console as standalone servers with a limited user license for development, and then you can deploy ISAPI libraries that are more efficient and are distributed separately from RAD Studio itself. You can run on Win32 and Win64, integrating on either versions of ISAPI, and use either Delphi or C++ Builder to build these packages that are deployed along with EMS. So an EMS package is just a package library. So it's a DLL with specific entry points. Each resource that you add to a package is mapped to a URI, a URL ultimately, a name that is part of your resource reference from your REST client REST calls. you can have an EMS server can load multiple packages, and each package can expose multiple resources. So you really have quite some flexibility in that respect. When you're using the EMS package wizard for the first time, you can add a resource, or then you can add further resources later on with the EMS module wizard. On the client side, the client can make any REST API calls with any technology. If you want to have a easier approach, use the EMS provider that also allows for all of the security and user management and login information that's needed. And then you can use some of the BAAS components like the backend endpoint or the backend user to interact with your EMS server. In the most simple scenario, just use an EMS provider with a backend endpoint, as we'll see in a second, to hook to your server. There is also a FireDAC client component that simplifies some of the code for interacting with FireDAC-based EMS servers. So, specifically talking about EMS and FireDAC, and that's the last thing before we get into demos, you can manually do JSON streaming of your FireDAC data, saving to stream and loading from stream with the JSON format. And that's actually the first demo we're going to go through, because it helps understanding the steps that are behind creating an EMS FireDAC server. Or you can use the more sophisticated FDSchemaAdapter that captures master detail relationships both on the server and on the client, and allows you to do streaming of this master detail structure rather than returning separately the individual database tables. So, as I was mentioning, let's start looking at a demo that I've built, and it's an EMS server and an EMS mobile client based on FireDAC, custom streaming, and EMS provider plus backend endpoint component. So how do we actually build an EMS application, or actually an EMS package to be installed inside the EMS server? When you create a new application, you can create an EMS package. Once you have an existing EMS package, you can add an EMS module to it. In both cases, the options you have is to create a data module or just a plain unit, and type in a resource name that will become the URL of your resource. And then you can pick some of the endpoints that you want to implement for getting, updating, deleting, or creating new elements. And the get has by default two options for getting the entire resource or one of the elements of the resource. So get an entire table or get further details from one of the records of the table. Now, I've already done this here, and this is my data module, and this is my class that only has the get operation available as part of it. So data will become the URL of our resource /data, and the only operation HTTP operation I'm implementing is actually the get operation. Inside the data module, I've added an employee connection component to get to my database server, and we can test that it actually works. There is a query that we can try out to make sure it's correct. And then we need a wait cursor and a specific component that enables the storage of the query results as a JSON data structure. So once we have these components ready, we can actually implement our server-side code, which is quite simple. It enables the database connection, runs the query, creates an in-memory stream, saves the query to the stream as JSON, and then returns the response. Here you can see we have a context of execution request and a response as parameter for our HTTP server extension or web server extension, if we want to consider an EMS package for its nature. And what we are returning is the body of the response as a stream, and also we can publish the data format of our server application. This is registration line that was added automatically for us. So what we can now do is actually run the server again in the context of, we are just loading a package in the context of the EMS server. In fact, if we go to the execution parameters, we can see that the host application is actually the development version of EMS server. Okay, so let's look at our server. It's here. There are a few information available. There is the information about the package that was just loaded, that we built. We can also open the local browser, and by default it opens in the version. This is one of the standard commands that are available. But now if we use data, we can see that the server will return JSON data structure for the database table. So it is working, it is returning the data. Now the next step, we have to keep this running. The next step is actually to look at the client demo. This is a very simple client form built with the multi-device designer, and it has quite a few components. It's more in the components architecture than there is actual code. So first we have an EMS provider that refers to the server, in this case localhost 8080 using HTTP protocol. The other option would be HTTPS. We have an endpoint that refers to the specific resource that's called data. And of course, it's tied to the provider. And the operation also that we are doing is a get operation, because that's what we have implemented. The result of this operation that we can actually even execute at here at design time is sent to this response object. It's not compulsory to have a response object, but it's actually nice to have and ready to use. Now the next step will be to load that response into a FireDAC mem table. That's something we'll have to write in code. The mem table already has a field defined for visual live bindings to the list view that covers the form. So if we open the live binding designer, you can see that the list view is tied to the full name that is a field of the FDMEM table that acts as a source database. So this is obtained through the visual live binding designer. These components are just dropped in, and again we need this JSON storage to drag in the proper units for that operation. Now, so the only thing we really have to do is to move the data from the response to the FDMEM table, and that happens when you do open. First we execute the back and endpoint. This is the HTTP request taking place. Then we create a string stream based on the endpoint response content, or honestly I could have used the response object. We reset the string position and load it inside the FDMEM table, indicating again this is a JSON source. And free the stream, and that's it. Once we load the FDMEM table, the data will be automatically displayed in the list view. So let's run it on Windows for simplicity. Open the table and we get our information in the list view. So again, there is some complexity, some components hooked, but it's few lines of code on the client and few basically symmetric lines of code on the server to make this database, this query, the result, to make this query result set available to the mobile client. For the second demo that's more sophisticated, we're going to use the FDSchemaAdapter. This is a rather complex demo that we'll spend a little time looking into, and actually it's a demo that ships with XE7, so you can easily delve into it and figure out how it works. In this specific case, the client is a VCL desktop application that just takes advantage of the local master detail relationship with data-bound grids, but of course it could be easily leveraged by FireMonkey mobile or multi-device application. The goal here is to look into how FireDAC can use and expose a master detail architecture, because rather than streaming individual tables, we are streaming information from the schema adapter that captures that relationship. This second demo that, as I mentioned, is one of the demos that ship with the product, with XE7. There is a resource module that has a connection, in this case to SQLite rather than Interbase on the server, and the driver, Hourglass, and again the JSON storage support. In this case, there is one new component beside two queries for customers and orders. There is a schema adapter. Now the schema adapter has some configurations options, and both the customer's query and the orders query refer to that schema adapter. So the schema adapter actually knows about the components and the tables that are being managed, that refer to itself. So what happens in the code is, rather than streaming out the two tables or the two query, the two result sets, what we can do is just stream out the schema adapter. This will create a JSON structure with the customers and the orders tied into the same JSON. So it's a single streaming of the records from two tables, from two separate queries. So this is a server. Let us running and keep it going here. And now let's have a look at the client application. The client in this case is actually VCL client. It has the provider, but now it uses a new component that's specific. It's a specific tie-in between EMS and FireDAC. It's a backend component that refers specifically to the output of that schema adapter. And again, it refers to the resource name in the module here. So the table, client-side application actually has another instance of schema adapter. This is the one that's going to receive the information. The schema adapter hasn't got local queries, but it has in-memory tables for customers and for the orders. These in-memory tables refer to adapters, and the adapters are actually tied to the schema adapter. So the information from the schema adapter can be sent into the in-memory tables in a rather straightforward and direct way, rather than having to go through the through manual copying of the data or manual loading of the data. So while there is a little extra work on the client side, on the server side, the client side becomes extremely smooth and extremely straightforward. As you can see here, this data module basically has no code, and the main form, when you hit the get tables button, all you have to do is just fetching the data from the given URL in this EMS FireDAC conduit. So there is a single line of code that you have to run on the client to be able to fetch the data from the server and populate, in this case, a master detail data structure on the client application. That's because the two tables also on the client side are connected in master detail relationship. This is the mem table, and this is how it hooks to the master source for the customers. Okay, so again, there is a lot of complexity hidden in the components, and the specific component that we are leveraging here is this special purpose FireDAC EMS client conduit that you can use to build desktop, but also, of course, mobile FireMonkey client application that use EMS. So we've seen that EMS is a new solution in the MEAP space. If you need an enterprise data conduit for your mobile application, that could be an extremely interesting option compared to do-it-yourself data snap servers, or compared to mobile backend that are limited in the reach to the enterprise data scenarios. EMS has ready-to-use FireDAC integration, and EMS and FireDAC are going to be further extended to work together even better in the future, although it's already marvelous what you can do with very few lines of code, as we've just seen in the last demo. There is very little glue code you have to write. All you have to do is focus on the business problem, focus on the core data access, and build the UI for your mobile or desktop scenario. There is little you have to do in terms of gluing together, creating the bits and pieces, maintaining the overall solution. You can really focus on the core and have a solution that provides end-to-end security with encrypted database data on device, and HTTPS-based secure connection to the server, and the server that will use a direct behind firewall connection to your enterprise database. So that's the scenario for EMS, and if you have any question, I'm here to answer them, or if you're listening to our recording, feel free to email me at marco.cantu@embarcadero.com. Thanks.
I'm new with JSON. Is there a documentation or manual or book that I can download?
Well, JSON.org. But beside that, I think I wrote some. I had a couple of REST in Delphi white papers like 2-3 years ago that also cover JSON mapping from Delphi and similar scenarios.
Are you ever going to do a fun side of Delphi again?
Well, I did it in Brazil 2 weeks ago, so I might do it again publicly. I'd say I need a lot of time to do a really new one, like covering FireMonkey and mobile, and so I'm not sure I'll find the time for that.
Is the FDSstan storage JSON link XML binary responding for sending the changes from client to server, or is it responsible for sending the changes from the client to server?
Well, yeah, I mean indirectly. So the storage is just a streaming, and as pointed out in the question, you can stream to JSON, stream to binary, stream to XML. If you look at the demo that I was showing, I kind of didn't really focus. There is a second part of that demo, and that demo ships with the product that actually shows how you can take the update cache or delta and stream it back again in JSON format and send it to the client. So there is full support for sending change and managing change in this architecture.
Are any of your fun sides of Delphi videoed on the web any place that you watch now? People that may have missed them?
I don't know exactly. I think there is an old website, web page on marcocantu.com/fun site that might have some of the old demos and old stuff. It's probably a page I haven't touched in the last 10 years, so as most of my website, honestly, but it is there.
All right, so about 9 minutes till top of the hour, and thanks, Marco, for this session on enterprise mobility services working with SQL databases.
Sure, more than welcome. I think my last session is coming next, and it's about building things I've figured out while building a public store app.